Thanks everybody for joining. This is kind of a product-focused talk, but don't worry, there'll be fun demos at the end for all the web engineers here. This is understanding the web, what product folks need to know. So I made the transition, somewhat unfortunately, somewhat not unfortunately, from an engineer to now a product program manager. I got to work on some really awesome sites, but as some of you might know, building a really great app doesn't mean anybody's going to use it or it's going to find success. So after a few examples of, I thought, well-engineered products not finding users, I started moving towards product. But because of that, I feel like I have a foot strongly in both places. So this is a kind of a talk geared towards a little bit more product people in the beginning of this. If you're experienced web dev, you can take a nap, I won't be offended. At the end, it'll be a little bit more fun and interesting. So are there any people here who would consider themselves kind of has at least one foot in the product world? Like a lot of people. Okay, awesome. That's great. So for those people, I'm going to go through. I'm going to go through fundamental web technology, just the basics. I'm going to talk through when engineers are coming to, can you please add CI, CD, things like that, things that aren't functional, that don't actually benefit users, what investments are worth doing. Then we're going to talk about web as a platform. Where can web be used that you might not realize it? And then what is the emerging technology available in the web? So that's what we'll kind of finish with. It's going to have to work on Heather's computer because her Bluetooth is working, but we'll show that web just recently has the ability to control Bluetooth devices. So see some other demos like that. All right. So let's talk through the fundamental technology. Again, for the folks, the software developers in the room, this will all be pretty basic for you. But I'm going to talk through a story of what happens when someone goes to a web page, in this case, like helloworld.com/index, and what happens when someone hits enter. There's a lot of stuff I'm going to kind of skip through, but these are the basics, and we'll kind of guide through how the core elements of web technology are all used to like build a site. So when you hit enter in the URL, a request is going to be made, an HTTP request, maybe HTTPS, hopefully HTTPS, but again, I'm going to get sucked into all the details. Keep it high level to a server somewhere, and that server is going to respond with HTML. Right? In this case, you can think of it as at this point just a document. Right? It's not yet doing anything fun or interesting other than saying hello world. The HTML, as the browser is reading the HTML, it's going to use something called the DOM, the document object model. There's no official logo. I created this one. I think it accurately represents the DOM.
Or exclamation marks.
Huh? Yeah. It's like trying to be good, but not quite there yet.
It needs a shadow.
Huh?
It needs a shadow.
It needs a shadow. Yeah. Shadow DOM and a light DOM. Yeah, use a DOM. So what the DOM is going to start doing is see this essentially string, this document, and start parsing it and doing things that the user is going to see. So it's going to start building elements that represent the HTML tags here. So it'll be like a document element, and a body element, and then I'll get to this H1 element. And since it has text, it's going to lay that out, and you're going to see hello world. Oh yeah, created an HTML hello world. Then it's going to continue parsing this document and find your style tag. This is CSS, and this is going to help control the visual layout of your website. Right, so here, I said H1s, I want the color to be green, and paragraphs, I want their color to be red. And so once this is fully loaded and executed on, the hello world will turn green. And then the next part, the kind of where often the magic happens, is the script tab. This is going to execute JavaScript, a language that runs inside web browsers kind of come with. And this is going to also manipulate the DOM to create a paragraph element set its text to welcome to the web and add that to the body. Because when these type of HTML elements are added to the body, it actually changes what you see. And now the DOM adds that paragraph and it says welcome to the web. So if you were a product person, this is all you have to know to be one of the engineers. So if you want to go in the other direction, that's it. That's all we do. All I ever did.
So easy.
Yeah, super easy. Okay, so with this core technology of HTTP, which is how you make requests and responses to servers, HTML, which is the document format, JavaScript, and CSS, an explosion of different tools and frameworks and things like that have come from that. Fortunately, you as the product person don't have to make the decisions probably on which technology to use, but you are extremely influential in what technology decision probably should be made. So as a product person, here's the list of things that I think are the most valuable to share with your team, to set that context so they know how to make a good decision on the technologies that they're picking to build the app. So the first is the feature set, of course. If you've got anything super atypical, that can radically shift what what technology you might pick. You've got something like a Miro kind of app, right? Can't really, I would not build that in like Next, for example, or React. So the weirder the feature that you anticipate, things that you don't see every day, make sure that's shared right away with the team. And then, so this is also like the what, the how much, and number 3 is the size of the team is the how much, and the number 3 is the when, right? Typical product stuff that you have to answer right away, but the size of the team might make, you can have a big team, a lot of people working. I tend to use more TypeScript than less TypeScript, right? But if it's like just me and someone else and we're like high-level engineers, maybe let's say it, like maybe I won't pull in TypeScript because it's just not worth it. The overhead of that, and especially if we got to get it done right away. I mean, I'm gonna throw some personal opinions in this. All the engineers will have different, for every engineer will have a different opinion on these things, but like I'm not going to use that if I got to be delivered real quick. If a mobile is going to be used, and we're going to talk a lot more about that, how important SEO is, how important is performance. A lot of times I think people overemphasize performance in the beginning, but if you're working on like an e-commerce site, every 1 second or every 100 milliseconds of load time is 1% of your users. So performance, like from the jump, becomes very important. Then people might, that's where I talked about Next before, maybe you start exploring Next. You can see the rest of my list. It's things like browser support, how accurate to the design spec you want the team to be. It's got to be pixel perfect and look perfect from the jump. Now you start pulling in design systems, maybe building custom design systems instead of just using like native HTML elements, native date pickers, things like that. Accessibility, display, dimension support, these are all good things to answer. A lot of times I'll use these as a definition of done. These things influence my definition of done as a product person. So now the engineers can kind of use that information to start deciding what to build, like what technology to build your app with. But there's other things that they're going to want to build and should, and a lot of times product people don't understand the value. And this is my prioritized order of best investments. And we just hear other people who would like swap like number 6 with number 2 or something like that. So for me, as a product person now, there's nothing more important than solid end-to-end testing on the most critical user journey paths through an application. I've worked on products before that had really great unit tests, good testing, CI/CD, but they forgot when someone goes to the homepage, that's where most of the searches happen. That's where new users are coming in and registering. There was a bug there, and they didn't know about it till like some fortunate users like, I can't use this site, right? A critical path. So I want teams to be releasing all the time, and I don't have to like worry that like the most important flow is somehow broken. I like to get up end-to-end testing. So the product people in the room, things like Cypress, you might have heard of, Playwright. There's a lot of other good technology out there that makes this pretty straightforward and easy to get going right away. And your front-end devs, it's not like Selenium days where you often had like a separate team that had to write end-to-end tests versus your engineers. Get your engineers writing end-to-end tests. Sometimes they don't like it, but it's worth it because then they can, if there's a bug, they can debug it themselves. They can run it right on their computer. I'm not going to talk through all of these, but that's one is I'm fairly convinced is worth the effort up front before you even like really start delivering features or as you start delivering features.
Is this the order you would put that into?
Yeah, number one. This is in order. So I workshopped it a little bit at Batovi, and people were like, engineers are like unit testing. No, it's good. Unit testing's for, but as a product person, I want to always ensure like we can ship to prod, and then fine, if this little thing is broken over here that I didn't get to end-to-end testing, okay, but like a user can sign up, a user can buy a burrito. Like that's what I want to make sure is always working.
What are the differences between 2 and 6?
2 and 6. Okay, so 2, that's your ability as like devs are pushing code. They might be pushing it to a branch, not to production, and you want your ideally end-to-end tests and unit tests to run, to verify the build is working, to execute all the tests and make sure that's working. So this is something that's like easy to set up now if you're using GitHub. GitHub Actions can run all your tests fairly straightforward. So that's continuous integration. Continuous deployment is how easy it is to ship to like prod and your different environments. Right? So it's very easy to migrate code from this environment to this next environment. I think if someone, especially if you have a lot of devs, the integration part is more important to set up because you want to make sure that like the devs can keep moving forward without breaking each other. When you're ready to deploy, if someone's got to like run a few scripts and spend an hour, that would still be a lot of time like deploying. That's fine, although dangerous, but that's why it's 6. Like you should still do this, but I have it as 6 instead of number. Like I still have integration first because I want my devs to keep being able to move and tests to pass. Error reporting. How many people use Sentry.io? One thing that's so surprising to me on the front end is how few places set up error reporting at all in their front end apps. Everybody's got error reporting on the back end, but so few people, even like big production systems, like get set up with like something like Sentry off the bat. Unit testing, everybody knows that. Stage and get your QA dev environment set up. Deployment we talked about, and then Storybook. I think is one thing that not a lot of product people know, or I might call it modellet pattern. I don't know if other people have a name for like what Storybook does. But what Storybook does is allows the developer to work on a component in isolation, right? So let's say you have a big app, and to click, sometimes you have to click through so many things. I worked on Sam's Club, and Sam's Club, in order to get like, there was one product and one configuration for the product that like you had to do all these steps just to get to that configuration and see how that worked. And the dev, every time they'd refresh, yeah, maybe some routing would help them get there, but there's a lot of work. Storybook lets the developer like show just that one component working on its own very easily. And that's nice as a product person because like they can develop more quickly, but also if they need to demo it, I need to see what it's going to look like. Often Storybook is deployed, so I can just check it out and talk with them about it, have a conversation. It kind of makes things more agile. So big fan of Storybook. Anybody, I assume a lot of people are here using Storybook. Yeah, almost everybody. Good to set up. Again, this is for the product people. Feature flags, I think most people understand what those are. And then branch builds. Branch builds are like a combination of continuous deployment and continuous integration. So if you make a branch, it will build a whole environment for that branch that then I can, like as a product person, I can check out, or people can look at, people can experiment with. Can be a little bit expensive, but worth. Anybody got branch builds set up in? Cool. Yeah, pretty easy to do the front end, harder to do for the back end folks because all your microservices or whatever. Definitely worth it. Cool. Any quick hot takes on like numbers that should be swapped? I want to hear like. Yeah.
I was curious about why you put feature flags very low when it can be beneficial in production if there's something that goes awry or whatnot.
I think feature flags are great. I think for it's hard to exactly say like end-to-end testing, like let me start with like the ones closest to it. So ability to release with, it depends on like where you are. There's such a nuance here. It depends on where you are. Like if I'm starting a new app, I need to be able to communicate a lot with like the devs and the design teams, and Storybook I find more useful. I'm not shipping all the time with like feature flags. I want to, but in terms of day-to-day, if I'm optimizing for like velocity, not necessarily like shipping, which maybe as a product person I should be, I might do Storybook for feature flags. I don't know, but where would you put it though? Where's your?
I feel like it shouldn't be a huge investment. Like it shouldn't take very much to set them up. And so I guess with that in mind, with that context, it seems like it should be much higher because it will allow you to manage like the actual product.
What do you use for like?
We use, at my company, we use this software, I guess it's a software as a service called Unleash.
Okay.
Yeah,
I did like use Optimizely, but that was not as easy to like set up and get going. So maybe it also is like the cost.
Also, I didn't set it up, so I just create feature flags sometimes. So I don't know if it's like you.
It
was already set up.
Feature flags, like it was, in my experience, it was like a bit more to get working than a lot of the other stuff.
Yeah.
A lot of the other stuff on here, but.
That's fair. No, I just was curious about what.
All this stuff, like I think, well, except for branch builds, which are hard and like are expensive. 8 through 1, I think, is kind of a must in any like production.
Feature flags could come along later, and it's not so necessary up
I
front.
could ship like my first iteration, like, is you got to get users on it. You know what I mean? And then I would add feature flags. Some of the stuff I would like, a lot of this other stuff I would do even before I like had users. Like just error reporting, I guess I would put further down if I was thinking about any users on it, but. Cool, awesome. Thanks for the take. Happy to keep discussing this. Okay, so now let's talk about the web as a platform, and this is as a product person. Like, can you use the web? Should you use the web? First, if you are building something that is you control the device, and the device isn't like an Arduino or whatever, has some real power behind it, you should almost build the web. Like now ATMs, things that control cars, kiosks. I helped work on one of these things that like sold earbuds or something like that. All of these things are all Electron apps nowadays. I don't, if it's just, sure, if you're building like a video game or something like that, but if it's your normal like point and click user experience, I don't see a reason not to like use a Cordova, or not Cordova, an Electron type environment. Set that up with Electron. Oh, for the product people, sorry. Electron is a tool, or it's a package that essentially takes a web app and can put it into a desktop app. So when you're using like VS Code, Teams, Slack, Figma, those are all built as web apps, and they just kind of fake a native app with it. Sometimes they'll reach out to like do, if there's high performance things they need, they'll reach out to do those things natively. But outside of that, most of the stuff that you're seeing is like HTML, CSS, and JavaScript at the end of the day. Anybody built an Electron app here? Yeah. Someone want to share the one they, huh?
It's been a long time.
So someone build a cool one they want to share or something?
I have a question.
Okay.
I've used like cross-platform, like mobile app frameworks, and I'm curious, this sounds very similar.
Yeah, we're gonna talk about that. Like,
I was gonna ask, I've never like used Electron, and I was curious if you can also make mobile apps with it.
it doesn't make. So I've made 1 or 2 apps with it. I made a kiosk, which is like a kiosk thing, and then that other was part of this, helping them a little bit. But didn't do the majority of the work. I don't even know what it's called. It doesn't make. You need to use Cordova or something like that to build the mobile apps. Okay. And we'll talk about that. But in summary, if you're a product person and you're thinking about like, you're not really necessarily thinking about a technology, but like you don't have to build a native desktop app for a lot of things that you might assume you would have to. Okay, so but then the next question is mobile.
Right.
This is really the big question nowadays. Is like, do you build a native app, 2 native apps, iOS, Android, and then build a web app? Right. Now there are tools that you can build once and then run everywhere. We'll talk about those, but these are the kind of the big questions. And then complicating this question is there are tools that you can build your web app and make it a native app in like a web view. But if you do that, the experience between like what people expect of a native app in Android does not match what they expect for the iOS experience. Right? You can see just the difference. What does it use? Material UI is Android's kind of standard, and this is
Human.
computer something. HIG. Is that what it is? Human interface guidelines. That's what it is. Thank you so much. And you can just see the difference. So if you take like your web app, it's not going to look like. I mean, you might make your web app use Material, but then it's not going to look like an iOS app. So how do you solve these problems? What kind of decisions do you make? What technology is there for you? So here's the different mobile app options. I'm going to come back around to progressive web apps, but progressive web app is you can just take a web app now and save it to your icons, and then so you can open it up and click it. That's an option. We'll come back around and talk about challenges with that, where things are with that. And then I would say there's kind of 3 different ways of leveraging the web for your mobile apps. The WebView hybrid frameworks. There's really React Native is kind of a special because it uses some of the web. It uses JavaScript still to provide cross-platform builds. And then there's the cross-platform native frameworks that don't use any web technology really, other than like you're not writing in web technology, you just outputs web technology. So let's talk through kind of these options. WebView hybrid frameworks. Anybody done a capacitor Cordova app here? Yeah. What did you?
Honestly, it wasn't. We ended up writing our own equivalent by like just writing little tiny wrappers.
Okay.
In both
like
Swift and Android, but it was essentially the same.
So you like just loaded your own WebView. Yeah. Okay.
But essentially, it ended up being the same.
Cool. So yeah. So what Capacitor and Cordova do is they load your web app in a web view. So it's kind of just almost like it's running the web page, but it appears like it's the actual app. These are great because you immediately can have, as like a product person, especially if you don't have a big budget. Anybody got a startup they're working on? Okay, good, cool. If you don't have a big budget, so just be able to say, I've got my web app, and now I've got a native looking, well, not look and feel, but native in terms of you can click a button and it opens iOS and Android app, and then you have to hire 2 other engineers to build that. That's mind blowing. That's great. And it uses web technology, which I like, so that's always a plus. The con though is traditionally the performance, right? It's you can get better performance writing a native app than a web. Just creates more abstraction between like the operating system and the bare metal that the CPU can do, and the display versus what like what you can do natively. And as we talked about, it's harder to get the native look and feel. Right? If you just take your web app, it's not going to look like a native app in iOS and Android. That being said, I've worked on a few of these apps. I love doing this approach, and it's great because you just like spend a day and then suddenly you've got native apps. There's a lot of work if you want to keep going. There's a few companies that have used it. Actually, there's a bunch of, in terms of who's using it and how to make that decision. Like big companies like Disney are using it, but none of them there's no big company as far as I know that's using it for its like public facing apps, like a big, every millions and millions and millions of users app. I don't know of any that are using Cordova. The biggest that I've heard of, Sworkit. I don't know if anybody's used this fitness app. Apparently like a couple million registered users. That's kind of widely regarded as the most successful version of this. Okay. So let's talk about the next one. This one is, I think, if you're building right this moment, this is probably the way to go. This is React Native. Who's on React Native here? Yeah, a bunch of folks. React Native, what it does is it allows you to write in JavaScript. So it uses some web technology, but the JavaScript essentially can call out to native components, native UI components. So that's essentially how it's working when it's building for Android or iOS. So you can get things to be styled the way that you would expect. It also has a web output. So instead of building like a date picker in iOS, it'll build just like the date picker in web. So this gets really good performance. They've done a lot of optimizations to make it run faster than a web view will. It uses JavaScript. So this is KC. I worked on that project. It uses React Native. And the great thing about it is you can code share between your web app, some code share between your web app and your React Native app. Right. So we actually didn't do so React Native can build out a web app, build out a native and the two native apps. We didn't do it that way. We did it where React Native builds out the native apps, but we had a separate web app build, but they shared code between them, like the model layers, the state logic, things like that. We shared across all of them. So you can kind of share some things, which is really nice, or you can just build it all out with React Native. Debugging can be hard. Oh, who uses anybody like CSS and JS here? Okay. Yeah, okay. That's okay. Some people like it. It's kind of an interesting idea, but I would say that for me, that's a negative. I'm not the biggest fan. It is slower than writing pure native. And debugging can sometimes be a challenge in React Native because you can kind of get lost if it starts getting like as they start communicating with native components, kind of get hard, at least for me to debug. But good technology choice. And then there's these. Anybody Flutter or any of these other ones here? Yeah, I've never worked. How's your experience with Flutter?
I haven't used Flutter very much. I've used .NET, which is maybe not this MAUI. I don't know what that is, but I've used Xamarin.
Okay.
Which is on .NET and C#.
Same kind of thing. Build once, deploy every. Anybody use? Yeah.
It's like its own rabbit hole. So you have to learn Dart, and then you have to dive into Flutter. Like it has its own thing going on. Like so like you have to learn HTML. So there's similar.
You still have to learn HTML.
So similar to HTML, like HTML,
there's its own version of HTML.
There's its own thing going on, and like it's like a learning everything once again. So like the whole setup and everything, it's like it's on its own.
Yeah. Yeah. What's up?
Like banking off of that, yeah. Like, and in my experience, you also just end up a lot of times needing to write like Kotlin or Swift code anyways, because these frameworks will just like build like the apps basically for you, and then you have access to like these like native files that you can modify. So there's like a lot going on with these, even though
Yeah,
the
just
goal
one-
is to
One
simplify.
thing to add on to what you say, in all of these, including even like the web view, you can access native components and native code. So you're not bound by, you're not like super tightly constrained about what you can and can't do. That is why I like when we can using the web view, because it's like, oh, you want this one, like, you want a map part. Well, that's going to be native. We're just going to call it to the native, but everything else around it is a web view. That I think with at least one consideration is, of course, know who your users are and what kind of phones they have. Because the higher performing phones, then considerations will matter less. There was another, yeah.
Flutter's, I feel like Dart is kind of on the vein of like early React. React, early at JSX, we were doing like React.create element. Similar patterns within Dart and Flutter. I was an Archon project where like the mobile was Flutter and the code base was like maintainable, but I found the code got very unwieldy very quickly. Flutter really thrives in building very fluid and performant UI experiences.
Yeah.
So, and again, that's where I think it's like a parallel of React for the mobiles, like agnostic, like fluidity driven.
Yeah.
UI.
That's what everybody say. If you really want to make the beautiful, expressive UI, Flutter, that's like kind of what it's built for.
Yeah.
But if you're like point and click kind of app, no crazy animations, then probably like React Native or like a web view technology seems to be the general consensus. Okay, so now let's get to the part that I'm most excited about, the emerging tech. Heather, make sure you have your computer handy if you're around. Okay, cool. So we're going to talk about the emerging tech in the web that might help influence what type of products you might develop and whether you leveraging the web makes sense or not. So there's kind of different categories I'm going to go through. I built demos for some of them. I found such good demos that didn't want to rebuild anything myself. And the categories are native-like features. This is just the web trying to catch up to like native mobile apps. I'll kind of go through what that looks like. Performance features is how to make the web technology as fast or almost as fast as like native experiences. Security features, which are like, being able to log in and do things like that, create passkeys, and then on-trend features. I didn't know what the right name was, but that's like machine learning is hot right now, and like it's almost like the web is at least keeping up with today's needs, where native like is really catching up to needs over the like last 10 years, and it's finally getting there. So let's go through it. And this is my best guess. If you see something like in the future, that's just my best guess based on, and I was working with this with somebody else, kind of divided up this, when I think it'll really just be available in mobile Safari based on like Apple's involvement with the spec, anything that they've said online about it. Generally, like Apple, if you follow these things, like if they have people who are like really working on the spec and agreeing to it, it's more likely they develop it. And plus we used as a baseline an average 5 years after Android landed the technology. So we kind of like, mobile Safari takes about on average 5 years after Google Chrome on Android has that feature. So this is just like, again, our best guess of when you can expect whatever feature it is. So let's start with the most important one, progressive web apps. I talked about this. Right now, you can, and I'll show the little demo in a second. See if this works. Okay. You don't see it. Okay, good. Now this is progressive web apps allow you to make an app appear like a native app on a phone. So there's like a web manifest that you have to fill out, but once you do that, and all this stuff, everything I'm gonna show works even better in Chrome in Chrome on Android. Here I can click the share and add to home screen. I give it a name, and now this appears just like a native app. An icon and everything. and it can open up and it opens up full screen. So this is where I talk about one of the options is just make a progressive web app. Now, the problem with that is, and we'll talk about the problem that is Apple underneath all of this and their app store that they want to protect the how much money they're making from. Apple's experience, as you saw, isn't great. If I had an Android phone, it looks much better. Android will tell you, oh, this is a progressive web app. You can install it. Like, it makes it obvious when you can do that and when you can't. It's kind of hidden here. And there's a lot of other problems with progressive web apps in mobile Safari. If I clicked like a link to a website, in this case, like a website that this should capture, you know, typically if I've got like Confluence app, if I've got the, oh, there's my family. Minus one of them though. I'm a bad. I gotta add the third. She's new. She's 1 year old. She's gonna earn a spot. We're talking about progressive web apps. They like, you know, if I have Confluence app running and I get a link for Confluence, I click on it and it opens the Confluence app. It does not do that. On Android it will, but it does not do that here. So push notifications are starting to work, but they're kind of a pain. But this is one option: is you want to like get people to install your app, just tell them to, you know, go to the site and install it. Okay. Next one. I don't have a demo for all of these. Push notifications. That is just now really working. It's mostly functional mobile Safari, so you can send a message to people for a push notification. I couldn't, unfortunately, get it, you know, all the demos I was trying to make, I couldn't get it to work in mobile Safari because it's a huge pain to have to register an app and stuff like that that we want to do. But here, I can show it at least a push message coming through here. Oh, there it is. Can you see it? Oh, you can't see it. It's hiding it. Zoom is hiding it. It's right there.
Sure.
So push notification, right? That's a real important thing to have in apps. Now that's finally like working because of legislation and pressure. Payment requests. I think this one does.
I have a question about push notifications in progressive web apps. Will that wake up a phone?
It will. I don't know if it'll wake up.
Yeah, that's like,
I didn't fully get it working.
okay, yeah, that's the thing I've always run into. Is like, I want my phone to go buzz, you know.
I think that's probably the person's settings. I guess it would just follow whatever settings. You know, in iOS you have like specific settings for like each on an app level. So it's probably related to that. Hold on, let me show the next one. This is the one that I'm most excited about. If it can actually land, because I think it'll be the most disruptive to like Apple's App Store, and that's the checkout. So now Apple only allows Apple Pay right now, which isn't so too surprising. But here, like I don't have to implement a like a your traditional like payment provider and all of that. You can just call out to like the payment API, and it will like go through Apple and give you a token that then you can use. You don't have to take like credit card. I mean, it'd be great to not have to have people be able to enter credit card information if they're on a phone. They just use their normal payment provider, and it's all, no one ever even my app never even sees. It's not even possible for my app to really see the payment details. Cancel it because I'm not gonna pay myself right now. Okay. Web share API. I'll come back around and do that one. Actually, so web share is now available. I click share, and it'll share. Right, that's great. Geolocation is now available. So it's gonna ask to be enabled and finds where we are, right? This is all native. I'm not doing anything anything special here. And these APIs are so easy to call. Device orientation, and this one, well, I guess she earned her place, you'll see. So this is gonna come out a little choppy, but here's a video game I made in WebGL, and it'll be hard to see, but like as I move, it like, yeah, it finds her, and she grows this little flower. It looks choppy there because of the streaming, but it's like, I mean, you take my word for it. I rendered like 1 million grass hairs, and it's pretty darn smooth, right? Like on my phone. And you can see the device as I like move my phone, that controls like how you move through the world, device orientation. Pure, you know, JavaScript web app here.
In a web browser.
This is what I did on paternity.
How long did that take you?
Yeah. Okay, media capture, that, so now we're kind of at the ones that are like becoming available. Media capture, web, so that's like you can capture a stream. That's available in Safari now, mobile Safari a little bit later. Web USB, file system API, contact picker, Bluetooth, all waiting on mobile Safari. Heather, if you're ready, I would love if you could go because my Bluetooth, I keep having it's my problem with my my Mac, not my. Yeah, are you able to? So Heather is going. Share my screen. Yeah, awesome. Take over. So, hopefully this is gonna work. Yay, okay, I don't know why my Mac is having a problem right now. Okay, so this is Bluetooth. Web app can just talk to Bluetooth now. And I've got my Arduino here connected to lights, and you can see I hit the red button, turns on the red, yellow, green. Right? My Christmas display is pretty awesome this year. It's just gonna be this out in the front yard. Now, here's the real cool thing. I wired up my this little joystick here to send where to control the little hand on my web app, and wherever the hand, when I push in the joystick, it's going to send a click event to the browser, and then when the click event happens, if I click on the buttons, it'll send a message back to the Arduino. So it's like this is being transmitted to the computer, and the computer is sending information back. So let me kind of like, I'll turn off the lights real quick. I shouldn't look at that screen. I should look over here. It's faster.
Whoa.
Whoa. Those claps are all for the engineers who brought this technology. Like, I mean, hopefully you're all excited. You can like build your own little Bluetooth apps at home and not have to like just in the web. That's so cool.
Sorry, now I have control over the lights and I got. I'll stop
Morse code. Like,
Yeah, right.
Twice if you.
Sharon, is it me again? Yeah. Okay. Okay. So went through those demos. Now there's so the web, as we talked about, like one of the sore spots is its performance traditionally, but there's technology that has made both the networking performance, the computational performance, and the like display GPU performance all much better. So WebAssembly, some of you might have heard of. This essentially is like bytecode that you can give to a device, and it will execute extremely efficiently. You have a lot of control over garbage collection and things like that, so you can make it run super fast. WebRTC allows, this has been around for a while, allows peer-to-peer communication. So if you wanted to make like a game where people talk directly to each each other instead of having to like go through a server. You can set that up with WebRTC. Web Transport is using HTTP3, which allows even it's like quick. If people don't know what that is, but it's the acronym for like the transport layer. But it's basically much faster connection, multiplexed connection, so you can get a lot more downloaded faster, and you can also do things like like what's it called? UDP is right, the one that's where it's not, it might drop, but that's okay because I'm just going to send the next thing anyways, so you can get doesn't have anything knowledge or whatever. And then Web GPU. So this is a real kind of almost belongs in like the future category. This allows you fine-grained control over how the GPU operates. You can write your own custom computational shaders, and it's also much more performant than like the Web GPU. So that's the final demo on the WebGL. Sorry.
WebGL.
So this is, oh no, it doesn't run on iOS, of course. So hold on. Forgot this is okay. So this is this 3D cube. This should now again, it's going all through. You can't see how smooth it runs. So smooth. It's so smooth, right? And this is with a web GPU, and the transformation is happening via WASM. So a WebAssembly. So this is like, it's kind of overkill for this example, but it's using all the cool tech. We went one step further. We would have used the shader to do the rotation instead of like WASM to call and do the rotation, but I didn't want to write a custom shader to do that.
It's a lot of math.
Over my head, yeah. Okay, so the security features, these get me really excited, especially because I didn't build the demo for these, because all of them have really great demos that you can look at, but I just want to show this one. Here you can create a passkey. Now in the browser, you can like essentially, there's an API you can call that will ask a device to generate a passkey and then save it in like a passkey vault. So here, I'm going to register. If I want it on my phone, I can do it on my phone, although I won't because I'll have to go back and forth. But here I can add it to my Chrome profile. And then it uses the like kind of authentication. Oh, I already registered this one. So this is, hold on, profile, continue. There we go. Okay. So what this did is it created like a public-private key, and the private key is going to be like stored in a vault, like on like the operating system, kind of like protected, like the way that your keys are protected in
Keychain.
Your keychain. Yeah, thank you. And essentially what it can then do is like there's well, I don't know how much the details I'm going to get here, but it's basically public-private key encryption, and there's a challenge. So someone can essentially validate that like this is in your keychain and you are who you say you are. And that's all through like a web request. It's really cool to have that kind of authentication. This one I'm more excited about. This is the federated, anybody use this yet? The federated identity management. So anybody implement OIDC auth flows here, right? Like everybody in the past. You'll never have to do it again, hopefully. So once Safari gets its act together, right? So what this is like in-browser OIDC flow. You could think of it as that. So this knows that like I've given my rights to this page before, and it's like, well, do you want to log in again? And it will essentially generate a token and give the token back to this page. So all of that like redirection stuff that you've had to implement for like an auth flow, it's like, I mean, look up the calls. It's like 4 calls that you have to make, and it will authenticate against Google or any other, it's like automatic Google login in a prop. Like you just add it. It's really great. And then yeah, I'm gonna skip that one because I'm way over on time. Let me talk about the final two things. Oh yeah, I forgot I talked about the most interesting one I think is now there's a spec for web neural nets. It's only available on Chrome on Windows. So I didn't get a chance to play with it yet because I didn't want to go buy a Windows box or set up a VM or something. But I actually think that will be available. Apple's participating quite a bit. I think that will be available pretty soon, especially since they have hardware support coming out with the new iPhones anyways. So be on the lookout for that. I guess final thoughts to close this out. Mobile Safari is holding the web back, right? But there has been some recent movement because of like lawsuits in the antitrust lawsuits in the U.S. and in the EU. I think a lot of good work is being done by this open web advocacy group. I'm not affiliated with them, but like if you're a web developer like me, maybe give them a few bucks so that they can make sure that like we all have jobs in the future and we're not have to become Kotlin developers or something. So I'm really hopeful. Like I feel like the tide is turning a little bit on the web. We've kind of been in a low spot, but now that regulators are trying and making progress, especially in the EU, to open up web standards again, so that everybody can operate in a level playing field. I'm really hopeful that like these kind of things, if you just want to do it, like it's 5 minutes, right? So thanks everybody. If you're interested in LinkedIn things, like me, you can connect with me on LinkedIn, and I'm happy to share any of the demos or talk. And if you're interested, if you're a product type person, I'm running a program management course November 19th. That's on the right. I'm not going to be nerding out on this kind of topics, but it's like how to effectively manage large multi-team projects. So thanks everybody, and
Thank you.
Take a break first or? No, okay. All right.
Yeah, of course, if any of you want to grab more drinks or more pizza, do it. Awesome. Thank you so much to Justin. And now we're moving on to Steve's presentation. And again, if you're listening in our virtual audience, feel free to relay questions in the Zoom chat, and then I can ask them directly to Steve. And then obviously you guys, feel free to ask your questions.
I brought my own right over there.
Beautiful.
Thanks.
Yes, of course.
All right, so just to start off, what this talk is probability and stats for software engineers. So a little bit about my background. Before I became a software engineer, I worked as an actuary, and I found that in my job, these sorts of kind of basic math problems can actually become pretty useful. And one of the reasons why it might be worth learning this is for people who get further in your career, whether you like it or not, your job becomes more product focused than you might otherwise want. And there's that quote, I forget who said it, where it's like, in God we trust, everybody else has to bring data. So when you're talking with like your stakeholders, they're sometimes going to want to know, how certain are you of whatever it is you're claiming? So just to kind of give you a roadmap for what I'm going to do over the course of the talk, I'm going to give 3 basic story problems, starting with a simpler one, and then ending up with one that's probably the most product focused of all of them. And then just trying to give some basic principles that you can use to kind of show what is, what are statistics I'm not going to give you a lot of formulas to memorize. So if I'm going to err on anything during this talk, it's going to be to oversimplify rather than, overwhelm all of you. But also, if any of you have questions during this, feel free to interrupt me, because teaching math is hard and I'm very likely not to be as clear as I think I am in my own head. So if you have a question, don't hesitate, go ahead and interrupt me. So here are the 3 problems that we're going to get to today. One is flaky tests. So if you have, say, a test that fails, maybe 1 time out of 6, you think that you fixed it. You run your test, it's green. How many times do you have to get a green test, a green build over and over again before you reach a certain level of confidence that you've actually fixed it? So that's going to be the easiest one that we're going to go to. The next one is more common, where there are intermittent errors. And so that can be any type of error, a seg fault. You could have like an API that times out, whatever it is, but it's something that just sort of occurs randomly with no pattern. And you don't know if you fixed it, but you think that you've deployed code that reduces the error rate. So you wait a little bit. How certain are you that you've actually fixed it, or at least reduced it, versus, could this be to random chance? And then the final one that we're going to get to, this is the most complicated one, is A/B testing, which is a pretty common use case if you're doing anything product-based. Like, say you get 2 versions of the same website, and they have a sign-up form, and one version has a slightly higher sign-up form than the other. How certain are you that that one's actually better? Separating out the signal from the noise. So in those 3 problems, there's kind of a common theme, which is, how likely is it that the thing I was seeing was due to random chance alone? Or is there something there? That's kind of the fundamental question that you're going to answer when you deal with statistics. And so when we look at how we approach these problems, this is kind of the fundamental thing of statistics. If you want to prove something, I'm just calling it X. The first thing you do is you say, assume that that's not true. And then say, if it's not true, how likely it is that I'm seeing what I actually see. And so everything else, all the other statistical formulas, just answer that fundamental question. So I'm also going to make an analogy to test-driven development, which Justin made some references to in his previous talk. But like in test-driven development, you want to prove that your code is correct. And so the first thing you do is you assume that your code has bugs. You assume the opposite. And you try to write as many tests to make those bugs emerge. And if they don't, you're not certain that your code is bug-free, but you're more certain than you were before. And so that's what statistics does, is you're not certain that your answer is right, but you're more certain than you were before. So now if we go back to the real world problems, let's start with the first one, which is flaky tests. So in this example, I'm just going to say the test fails 1/6 of the time on GitHub Actions. You think you fixed the flakiness. You run it 5 times and it's passed. How confident are you that you've actually fixed the test? So the math for this, I'm going to go one step back. You want to take the thing that you want to prove. So you want to prove that you fixed the test. So you assume the opposite. You assume that you've not fixed the test, which means that if you haven't done anything, it's probably going to still continue to fail 1/6 of the time. And so how likely is it that you see what you're going to? If it passes just once, that's going to be a 5/6 chance. If it passes twice, 5/6 squared, 3 times 5/6 cubed, et cetera, et cetera. So in this case, if it passes 5 times in a row, you're just going to go into a JavaScript console, math.pow, 5/6 raised to the 5th. In this case, it's about 40%. So if you want to be, let's say if you want to be 95% sure, you're going to keep running more and more until you are certain. Now, being 95% sure is completely arbitrary. That's a convention in statistics and mathematics. How sure do you need to be? It depends on what problem you're solving. So, if you're building a space shuttle, you're going to need to be a lot more certain than if you think you might have fixed a flaky test. But this is another principle that I'm going to bring here, because a lot of formulas in statistics, they're difficult to remember and they're easy to get wrong. And luckily, it's actually pretty easy just to run a simulation. And so I'm going to do that right here. Monte Carlo is kind of a fancy term in finance for simulation, but Monte Carlo just means simulation. So what I'm doing here for the flaky test By the way, how is the font size, everybody? Should I, okay. Let's say that you run it 5 times, and every time you run it, if it fails 1 time out of 6, it's gonna pass 5 times out of 6. And so I'm gonna go through each of these, and you may not have used this before, but math.random is a function in JavaScript that just returns a decimal between 0 and 1, and every decimal is just as likely as the other one. And so if I ever use the term random variable, it is a function that returns back a number at random. And so that's what we're going to do here is, let's say that we have, I cannot seem to, there we go. So we want to say, hey, we're going to run 5 tests, which was the story problem, 5 builds on CI. And how many do we get to pass? In this case, 80% of them, because I'm saying, 4 out of 5, passed. Keep doing it again. 1, 80%. It's different every time. That's the thing with a simulation is it's different every time. So if I want to figure out on average how many it's going to be, I just run a whole bunch of simulations. So if you see here, I'm actually going to run 100,000 trials. And I'm going to do this over and over again. I'm going to say how many times do all of them pass? And so that's what the code is doing over here. And so if I run that, JavaScript engine is so fast that it's like running 100,000 scenarios just goes like that. So it looks like I get about 40% of the time, which was the same as what I got over here when I put that closed form solution in. Now, the benefits of running a simulation are when the problems become more difficult than this, you don't have to remember everything. And so a couple of other things to learn is that as we increase the number of successful builds, we become more confident in our answer if the results continue to be the same, which probably is might be intuitive. The more data you have, the more confident you are in your results. And also, as you increase the number of trials, like if I ran 100,000 trials instead of 1,000 trials, that number that I get gets more stable. And so that's what's known as the law of large numbers. So when you run a simulation, it's not going to give you an exact result, but if you keep running it over and over again and it barely moves, you probably have a large enough sample size. So that was the first kind of easy problem. Before I go further, are there any questions? Cool. All right. So here's the next one, intermittent errors. If you have, let's say a seg fault error that happens 5 times per week on average, and you think that you've deployed code to reduce how much that happens, not eliminate it, but reduce it. You've gone 2 weeks. Before you would have expected 10 errors to happen on average over 2 weeks, but you only see 8. You want to determine your level of confidence that you've actually reduced the error rate. And this is something that a client or like a product manager might ask you is like, how confident are you that you've actually fixed this? And so going back to first principles, you take the thing that you want to prove. You want to prove that you've lowered the error rate. And so you assume the opposite. You assume that you've done nothing, which means you would see 5 errors per week, as before, 10 errors per 2 weeks. And so how do you model this? So to get into that, I'm going to use a couple of terms. There's something in math that we call the binomial distribution. And what that just means is like you flip a coin over and over and over again. It doesn't necessarily have to be a fair coin. Another analogy that I use in these slides are you take free throws. So if you take 20 free throws and you make a quarter of the shots on average, what is the probability that you get 8 shots in out of 20 or 10 shots in out of 20? That's the binomial distribution. And so when I pitched this talk, Heather actually suggested that there is a library in JavaScript called JStat, which can answer these sorts of things. I'm going to go pull up the library over here. So if we have jstat.binomial, you want to say how likely is it that you got 8 shots out of 20? I'm going to use something called the PDF, the probability density function. And so here I'm going to say, let's say I make 8 shots out of 20, and I make on average 25% of them. That's going to give me back a number here, 6%. That's actually kind of small. And so this is another important concept here that I'll get to later is you want to say how likely is it that you make, if you make on average 5 shots and you made 8, you want to say how likely it is that you made 8 or more. But with something like it, let's say with a seg fault error, what is the denominator here? Like how many free throws are you taking? You don't know the answer to that question. You just know that it's like a really, really high number. And so we're going to use something else called a Poisson distribution, which is basically, imagine if somebody takes free throws and they make on average 5, and then you get an increasingly worse player after that each time who takes more and more free throws, but still makes on average 5, and you continue that pattern. That's what a Poisson distribution is. So like if you really wanted to think about it, like imagine there's a very small chance of an error every time there's a CPU cycle. But on average, you get 5 per week or something. That's what this distribution models. And I'm just gonna put up a little graph here that I built in ChartJS to show that. So, let's say you have, 10% chance that any given user signs up. So the green curve here with the solid line, that's the binomial distribution that I showed you. The red curve with the dotted line is the Poisson approximation. So if 10% of the people sign up, it's not a great approximation. But if 1% of the people sign up, then you can see how these two numbers, almost align very closely. So the benefit of using a Poisson distribution is you don't need to know that denominator. You just need to know how many times does that thing that I'm measuring happen on average. So like how many seg faults, how many timeout errors. So we're going to go back to the story problem here, which was you had 5 per week, and then you think that you've reduced it. So now you have 8 in 2 weeks instead of 10. So how likely is it that you're going to see what you do? So kind of going back to first principles, when in doubt, run a simulation. And if we do the same thing here where we just simulate how many errors that we get, and then we just run a bunch of trials, we're going to get back an answer. And so in this case, this is going to give us an answer that's pretty close to 40%. And it's going to be a little different every time. Okay, oh, sorry, I got that wrong, 33%. 40% was the previous example. But we can also, in this case, we do have a simple formula. And so if we go into JSTAT and get the Poisson distribution, we use this thing called the cumulative distribution function, which says, what are the probability that there are 8 errors or fewer? And that's really important, is that we want to use the cumulative distribution function. So if you look at this graph here, that's saying, what is the area in green? What is the probability that your random variable, that function call gives you a value less than or equal to the value? So in statistics, we're very infrequently dealing with equalities. Often we're dealing with inequalities. And so why do we deal with inequalities? An example is like, let's say you're flipping 1,000 coins and you get 496 heads. You say, how likely is it that I get exactly 496 heads? It's about 2%. But that's not a remarkable event, flipping 1,000 coins and getting 496 heads. So the more relevant question is, how likely is it that you get 496 or fewer heads? And so in that case, the answer is about 40%, pretty normal. And so that's why you use these inequalities when you're dealing with statistics. I'm going to stop there because I've given you a lot. So if there are any questions. Cool. All right. So now here's the big one, A/B testing. In my example here, there are 2 versions of the page, and you want people to subscribe, to sign up, whatever the case may be. In version A of the page, 100 people have visited, 10 people have signed up. In version B of the page, 100 people have visited, 13 people have signed up. How confident are you that version B has a higher conversion rate than version A? And so we're going to go back to first principles. I'm not going to go through all the mathematics because this is only a 30-minute talk and I don't want to overwhelm people. And so that's why I kind of went to the first principle of, if you don't know what to do, you can write a simulation with just a couple of lines of JavaScript. And so that's what I'm going to do here. So again, in first principles, you want to prove that version B of the page has a higher conversion rate than version A, but you assume the opposite. You assume that there is no difference between the two, that they're exactly the same. You've got one placebo and one placebo. And so if the conversion rate is the same, we're just going to say 200 people have visited both versions of the page. A total of 23 people have clicked. And so it's an average of an 11.5% click-through rate. And then you say, how likely is it that we're going to see what we do. And this is a very important concept here, is when we started the A/B test, we didn't know which version of the page would have a higher response rate. It could have been version A, it could have been version B. So you have to say, how likely is it that either version of the page has a click-through rate that's 30% or more than the other one? This is what's known in statistics as a two-sided test. You want to say, what is that area in red underneath the curve on either side? Any questions about that? Because that's kind of a fundamental topic. Go ahead.
Can you elaborate why we don't know if like the data showed that one had 3 more than the other? Like, why do we say that we don't know?
The question was, why do we, well, can you repeat the question?
Why don't we know which version A or version B has a higher click-through rate if the data is showing that version B potentially does? I guess I kind of.
Yeah, because at the time that you design it, it's like you don't know ahead of time. You only know it after the fact.
Okay.
And so an example where you would not do this two-sided test is something like, let's say, you're making Ozempic or a weight loss drug. You think, well, it's either going to have no effect or people are going to lose weight. You don't think that that drug is going to make somebody put on 30 pounds. So in that sort of example, you would do a one-sided test because you wouldn't reasonably think it would go the other way. Does that make sense? Yeah. So the original question for people listening is like, how did you know that it could go either way at the beginning? Good question. And so now there's a lot of math here, and so I'm going to go over this quickly. Is that you just go through, there's something called a normal approximation, which is like a bell curve. You say, what's the combined rate? How different is it? And then you go through all of this stuff, and you get that the answer is about 50%. I'm not going to try to go through all the steps. If we have time later on, we can. But that's the thing, is like if you go through these formulas, it can be easy to forget all that stuff, which is why I say again, when in doubt, run a simulation.
So
Go ahead. Yes.
It's the 50%?
The
50% that it's significant, or 50% that it's the same, that there is no difference?
Okay. So it is, if there is no difference, like if there's no difference between the two versions, there is a 50% chance that one of those would have had a click-through rate that is 30% higher than the other or more. Right.
So it's quite likely that there's no difference at this point.
Yeah. You just, it's quite likely there's no difference. Exactly. And so if you want, to know that, if you want to be more sure, then what you do is you just wait until you get more data. So what I set up here as a simulation was just a click-through rate where I say, if, say, 100 people are visiting, and on average, 11.5% of them actually sign up, I'm just going to simulate that for each of them. Say for each one, if that random value is less than 11.5%, sign them up, and then say what percentage of them at the end have signed up. And then just repeat that over and over again. In this case, 100,000 trials. I'm going to say, what was the sign-up rate for version A? What was the sign-up rate for version B? And then was the difference between the two of them 30% or higher? And then when we run that, we get very close to that 50% that I showed you before. But if we just do a brute force simulation here, we're going to get 49%, 49.975. These numbers are very close. The advantage of running a simulation like this is you don't have to remember all of those normal approximation, how the variance of a sample, changes over time. You can just run it and you can find out. But there's some things that you can learn from this. I'm going to see if I can open up a.
Quick question.
Go ahead. Yeah. Go ahead.
Is that is there any difference if you're comparing 10 to 13 with 13 to 10?
In this case, no, because ahead of time. So the question was, is there any difference between comparing 10 to 13 versus 13 to 10?
If you're running your simulation and you were like, well, how often is 13? If you assumed like a 13% conversion rate.
Yeah.
How often does that match 10? Like how often will that be? You'll get a 10 in your simulation versus you have a 10% conversion rate, how often you get a 13? Are they symmetric in that way?
So what I was doing was I wasn't, there are a couple of ways you could do it. One way that would get you a similar answer is you say, well, if you started with a 10% conversion rate before with a page, and you're like, does this one make a difference? You could say, what's the probability with a 10% conversion rate, if I haven't made anything better, that I get 30% or more improvement? In this case, the question was, you don't know which one is better. And so you're saying like what is the probability that the two of these are this far apart from each other? Does that make sense?
Yeah. Does that kind of indicate if it's worth it to go to the version B or not? So
exactly, yeah.
So if the effort is too much and the difference is not that high, we are kind of measuring the difference, right?
Yeah. So the question was like, is it worth it going to version B or not? At that point, that becomes a business question because like, let's say, is it a very expensive product that you're selling where, millions of dollars are on the table? What's the cost of getting it wrong? Like at that point, you need more than just this specific simulation. What was it? Yeah.
What you're measuring is the amount of difference that does this make, right?
Yeah. What you're measuring is how likely is it that this difference would occur if there were no effect whatsoever. Does that make sense?
Yes, I think so.
Yeah. And so the less likely that is, the more likely that it is that there actually is a difference between the two. And so let me go back and kind of copy and paste my code over here, which is that, what did I do wrong here? Let me copy this one more time. I accidentally opened up a new Chrome window, so I'm not sure exactly what I'm sharing anymore. All right, let me go back here. There we go. So some general rules about like how statistics behave here. So we're getting this, the first thing is like, if we increase the number of page visits per trial, that final p-value, the chance that we saw this by random chance alone gets smaller. So in this case, we had 100 people, visiting each version of the page. If we wait longer and the results still kind of look the same, so let's say, we have total visits instead of 100 per version, it's 1,000. Now, instead of it being 50-50 chance, this was totally random. Now it's only a 3.5% chance that it's totally random. So if you wait 10 times longer and get more data, now you're a lot more certain. So that's the first thing. I mean, that might be, you probably could have guessed that beforehand. Also, like if you increase the number of trials in the simulation, the result becomes just more stable. So if we're running this simulation here and we go total trials, instead of 100,000 trials that I did here, let's say if we only run 50. Oh, thank you. Yep. So now we're going to see it. The value is going to bounce around a lot more if you don't run that many trials in your simulation. So it's really cheap in a lot of these scenarios just to run a bunch if you're not sure. And if you're not sure if you've run a bunch, keep running it over and over again and see if the result changes a lot from one time to the other. And then the other thing is, if we increase the difference in the click-through rates, we need less data before we're certain. So it's like the stronger the effect is, the less data you need before you're certain of something. If it's like a 1% difference in click-through rates between two versions of the page, which is probably something like on a scale of Facebook, you're going to need the scale of Facebook data to be able to know one way or another. So those are just kind of some general principles about statistics in general. So before I go into some like bonus math concepts, I'm just going to stop here and see if there are any other questions.
Cool.
Go ahead.
Any advice for how to get better at devising the trial itself?
Yeah, that is
coming up with a simulation is the key. If you can come up with a simulation, you're good. But what if you're stuck at that?
Yeah. Boy, knowing the right question to ask is one of those that's always difficult. Like at that point, I would say talk to somebody who, has a stats background or something, ask them the questions. I think you've got a bit of a math background, so I'm not sure if you have, some ideas of your own, but yeah, that's a good point. So, go ahead, yeah.
Like, when you say like run a simulation, sometimes you still need like real world data to be able to do that, right?
Right, when you set the parameters, so for instance, the thing that you said was sometimes you need real world data for a simulation. You kind of need real world data for the assumptions of your simulation. So for instance, when I ran this A/B test simulation here, I made some assumptions. I made an assumption that 100 people visited each version of the page because that's what the real world data was. I made an assumption that the click-through rate was on average 11.5% because that's what the real world data was. So it's like your real world data informs the assumptions, the parameters that you give to the simulation.
It's like, I made a feature, I made an observation, now I run this simulation.
That's right. Yep. So some bonus math concepts here. One of them is the central limit theorem, which I used in the math formulas that I very briefly showed all of you, which was that if you do the same thing over and over again and you sum up the results, it tends to look like a bell curve. So this is an example of what's called a Galton board, where these balls just move randomly, and then they go back and form kind of a bell curve in terms of where they end up. So, if you remember The Price is Right when you were a kid, that was the Plinko game. And where they end up kind of forms a bell curve. So that's probably the best visual demonstration of the central limit theorem. If you want to look at click-through rates was binomial distribution, which I mentioned to you before. So let's say if you have, 100 and, 11.5% of the people sign up, you can see that the binomial distribution is in green. The normal approximation is in red and dashed. You can see that it's pretty close. It's not perfect, but it's pretty close. And so the advantage of using normal distribution is you only need to know two things. You need to know the mean and the standard deviation. So the mean, that's the average. It's like how far to the left or to the right is that curve? And then the standard deviation is how spread out is it? So in this example here, the red curve and the blue curve both have the same mean, but the red curve has a much smaller standard deviation. You can see it is much more narrowly spaced, and the blue curve is much more spread out. So the less of a standard deviation you have in your data, the more confident you are of the results. And so, again, another concept is like the variance of the mean. So in the example that I gave in the A/B test, 200 people visited both versions of the page combined. And you want to know, well, if I took a completely different set of 200 people, how close would the results be? How different would they be? And so if it's not going to be that different, then the variance of the mean is smaller. The variance is another, if you take the standard deviation and you square it, that's the variance. But I should have said probably standard deviation of the mean, but I'll go back and change that slide later on. And so, yeah, that was the question that I just answered there. So those are just some high level mathematical principles. But again, there's a lot to remember there, which is why I kind of said, when in doubt, run a simulation. So in conclusion, in statistics, you take the thing you want to prove, you first assume the opposite, and then you see if the opposite is true, how likely is it that I observe the results that I do? And the less likely it is, the more confident you are in your original conclusion. And then when in doubt, run a simulation. So that's all I've got. Any questions? Go ahead.
A personal question. Are
Absolutely.
you like a professor? Or?
I am not.
You should be.
I'm a software engineer.
You should be one. Did you go to, where did you go to school?
Wisconsin.
Or did you do like graduate school?
No, I majored in math.
Oh, okay, there you
And
go.
back when I was in actuary, I took a lot of those actuarial exams. So like one of the exams was probability.
Thank you very much.
How Poisson distribution come into your play? I mean, Poisson, you see the mean equal where mean and the median is the same, right?
Yeah, so in a Poisson distribution, the mean and the variance are the same.
No, mean and median.
The mean and median are the same.
Yeah.
That might, I don't know. Let's look that one up. Yeah, that might be true. I don't know if that's the case.
Well, that's the definition also.
Let's see here.
Doesn't make sense.
Yeah, I forget that might be the case, but for the rest of you, it's like the median is half the numbers are above this value, half the numbers are below this value.
Median is in your data distribution is most commonly appeared number.
The mode is the most common, but for something like a normal distribution, the mean, the bell curve that I showed you, the mean, the median, and the mode are all the same number.
Mean is average of the number of the data.
That's right. Yeah, the mean you just sum up the data and you divide by the number of samples.
How distribution come into play in your data?
What was the question about Poisson distribution?
I mean, Poisson come into your you use Poisson to compare with the binomial, right?
Yes.
Poisson is the mean and median is the same. So I just wonder how come you use Poisson in your
Yeah, so the reason why I use Poisson instead of binomial is in real life, you don't always know what the denominator is in binomial. So it's like, car crashes or earthquakes and things like that. You don't necessarily know, radioactive decay. You don't know what the denominator is in binomial. You just know that it's very large. And the Poisson distribution is the approximation when that denominator gets very large. And so the advantage of a Poisson distribution is you only need to know one value. How many times does this thing happen? Does that make sense?
Yeah. So it's consistent with the mean and median same. So that's the same idea now.
Okay. Oh yeah, go ahead, Justin.
So, the Poisson, does it go out left and right to infinities?
It does. It is. Go ahead.
Well, then is it a right fit for kind of like you can't have negative conversion.
Oh, okay.
You can't have like beyond 100%.
Got it. So the lowest value of a Poisson distribution is 0. The highest possible value is infinity, but it becomes so absurdly unlikely that you almost don't even have to worry about it.
How does it compare to log normal? Log normal is like that too.
So, I mean, Poisson distribution does not look logarithmic. Log normal does. So if we go back to, let's see if I can see if I have this graphed out here. Let's see, binomial versus Poisson here. So if we do 300 visits and on average, let's say 3,000 visits and on average, 1% sign-ups, you're going to get like 30. You can see that, okay, sure, it is technically possible that 1,000 people might sign up or 10,000, but it becomes so
more than 3,000, or what was the?
Oh, so I said if 30,000 people visit the web page and only 1% sign up.
But there is a possibility that 30,001 could sign up.
That's that. Yeah. In Poisson distribution.
Yeah, that's
yes.
okay. Yeah. Oh, yeah, but it doesn't have the log normal okay. And
Yeah. I'll try to think if I can give an example in programming. If any of you know how to do quicksort, it's like there is a possibility in quicksort, if you start with a shuffled list, that it's going to be order of n squared, but it's exceedingly unlikely. So it's like you don't have to worry about that if the data is shuffled. Poisson distribution, yes, it is possible that you get some absurd result, but it is so unlikely. It's like worrying about a hash collision. Any other questions? Cool. All right. Thanks, everybody.